Welcome all to today's lecture. Myself Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The lecture series that I am covering in my series is for the subject embedded system, and the subject code is KOE 062, which is an open elective. The topic that I am going to cover today is multiprocessing and multitasking. So, we will understand both these topics, that is multiprocessing and multitasking, and will try to differentiate between these two. What is multiprocessing? As the name is suggesting, there must be some multiple processes going on. So, for the multiple processes to take place in a single system, we need multiple CPUs, that is central processing units. So, the ability to execute multiple processes simultaneously is referred to as multiprocessing. Systems capable of performing multiprocessing are known as multiprocessor systems. So, the systems that are capable of performing multiple processes simultaneously, that is at the same time, we consider them or we call them as the multiprocessor systems. Multiprocessor systems possess multiple central processing units. Due to the presence of multiple CPUs in such systems, they are capable of performing multiple processes, or they are capable of executing multiple processes at a time. And or we can simply state that multiprocessing is the use of two or more central processing units, that is CPUs, within a single computer system. So, in layman language or in the simple words, we can say that the systems which are capable of performing the multiple processes simultaneously due to the presence of multiple CPUs in them, those are known as multiprocessor systems, and such processing is known as multiprocessing. We can categorize the multiprocessing systems into two types, that is asymmetric multiprocessing system and symmetric multiprocessing system. So, let us understand what are the differences between these two. When we talk about asymmetric multiprocessing system, as the name is suggesting, the asymmetric term, it means there must be some asymmetric idea about the system. Let us understand what is the asymmetry in this. So, asymmetric multiprocessing system is a multiprocessor computer system where not all the multiple interconnected central processing units are treated equally. So, this is the asymmetry in the system, that all the CPUs which are working together in such systems, they are not treated equally, that is they are not allotted the task of equal types. Let us see what is the difference. So, only a master processor runs the tasks of the operating system. So, all the job of the operating systems or all the responsibilities of the operating system are handled by the single processor in such systems, and all other processors apart from the main master processor, they are allotted to perform some other types of tasks. So, this is the asymmetry, because only one CPU is treated as a master and others are treated as the slaves, or we can say others are not treated as the main controlling master CPU. For example, asymmetric multiprocessors multiprocessing can be used in assigning specific tasks to CPU based on priority and importance of the task completion. So, all the CPUs which are involved in multiprocessing in the asymmetric multiprocessing system, so the CPUs are allotted the tasks according to the priority of the task or the importance of the task completion. So, this is the figure representing the idea of asymmetric multiprocessing, that there are different processes, process 1, 2, 3 and 4, and the master processor is performing a particular task and all other are treated as the slave processors, and they are performing some other types of processes. So, this is the idea of the asymmetric multiprocessing. When we talk about symmetric multiprocessing, it involves a multiprocessor computer hardware and software architecture where two or more identical processors are connected to a single shared main memory, have full access to all the inputs and outputs devices. So, we can see that in symmetric multiprocessing systems, all the CPUs are treated equally. How? Because they are connected to a single shared main memory and have full access to all the input and output devices. So, in this way they can access all the resources, all the input output devices, they are sharing the same memory. So, they have given the full access to all the resources equally. So, no particular CPU is treated as a master and others are treated as the slave. There is no such scenario in symmetric multiprocessing systems, or in other words we can say it is a type of multiprocessing where each processor is self scheduling. So, here the scheduling, so each process has a particular schedule in itself and it acts accordingly. For example, symmetric multiprocessing applies multiple processors to that one problem known as parallel programming. So, the parallel in symmetric multiprocessing systems, parallel programming is the perfect example. In parallel programming, all the modules are being executed or processed simultaneously at the same time. So, all the resources are allotted to all the processors and all the processors are treated equally in such cases. In case of symmetric multiprocessing, see this is the figure representing the idea that all the CPUs have the equal access to the system buses and to the resources, and they are executing process 1, 2, 3 and 4 simultaneously and are treated equally. So, let us differentiate asymmetric and symmetric multiprocessing. In asymmetric multiprocessing, the processors are not treated equally, and in symmetric multiprocessing all the processors are treated equally. We have seen that because all the resources are allocated to all the processors in symmetric multiprocessing. So, all the CPUs have equal access to all the resources in this case. Tasks of the operating system are done by master processor in asymmetric multiprocessing, and tasks of the operating systems are done by individual processors in case of symmetric multiprocessing. No communication between the processors is there as they are controlled by the master processor in case of asymmetric multiprocessing. So, we see that in asymmetric multiprocessing there is a master CPU which is controlling all other CPUs as the slave. So, there is no communication between all the CPUs in case of asymmetric multiprocessing. So, there is always a slave master relationship in this asymmetric multiprocessing. But this is not the case in symmetric multiprocessing. All the processors communicate with another processor by a shared memory. In asymmetric multiprocessing, the processes are master slave, and in symmetric multiprocessing, the process is taken from the ready queue. So, in case of asymmetric multiprocessing, there is always a slave and master relationship. So, the processes are executed in that way only. The master CPU is the controlling device and all other CPU devices are being controlled like just like the slaves. In symmetric multiprocessing, the process is taken from the ready queue. So, there is a ready queue and all the processes are uploaded there, and all the CPUs access that ready queue equally and access the particular process for execution. In case of asymmetric multiprocessing systems, these are cheaper, but the symmetric multiprocessing systems are costlier because they are the symmetry has to be maintained, and for that the complicated circuitry has to be used. So, they prove to be costlier. Asymmetric multiprocessing systems are easier to design, symmetric multiprocessing systems are complex to design. So, maintaining the symmetry between all the processors and giving the access to all the processors to all the resources available, input output devices, memory, etc. This makes the system bit complex, and so the symmetric multiprocessing systems are quite complex as compared to asymmetric multiprocessing systems. Now, we come to the term multitasking. So, we are clear about multiprocessing, that in multiprocessing systems there are multiple processors, that is the CPUs available within a single system. Now, we will talk about multitasking. This is not the case with multitasking. In multitasking there are not multiple processors available. So, when we talk about the CPUs or the operating systems, now the kernel is the core component within an operating system. Operating systems such as Linux employ kernels that allow users to access the computers simultaneously, all the computer uh, seemingly simultaneously. Multiple users can execute multiple programs apparently or concurrently. So, we will many a times you will see that multiple users can access the same programs and can execute different modules simultaneously within the program. So, each executing program is a task or thread under the control of the operating system. So, within the same operating system there is a single CPU and there are multiple tasks that are being performed by different users. So, that is the case of multitasking. If an operating system can execute multiple tasks in this manner, it is said to be multitasking. Thus, multitasking refers to the ability of operating system to hold multiple tasks in memory and switch the processor, that is CPU, from executing one task to another task. So, this is the basic difference between multitasking and multiprocessing, that in case of multiprocessing there were multiple CPUs handling the various processes, but in case of multitasking there is a single CPU and it will switch from one task to another when in need and will execute all the tasks on the time basis. Like it will keep switching from between the various tasks and will try to perform the tasks according to the need, according to the time division. So, this is the way the multitasking takes place. So, this is the ability of the operating system to hold the multiple tasks in the memory and keep executing them by switching the processors from one task to another. So, this is the basic difference between the multitasking and multiprocessing. When we talk about multitasking, so it involves different phases. What are the different phases? There is the context switching, there is context saving and there is context retrieval. We will now understand these terms, that what are these meant for. So, context switching refers to the switching of execution context from one task to another. Let us first understand the term context. So, here I have placed a note here that a task context. What is a task context? It is a minimal set of data used by a task which may be a process, thread or fiber. So, what all the data related to a particular task is present, that is known as the context. The context data may be located in the processor registers or the memory used by the task or in the control registers used by some operating systems to manage the task. So, these are the various options where these context may be available. So, when we keep switching between the context, means we are switching between the tasks, so that context will obviously keep on changing because different tasks are having the different context related to them. So, when the processor keeps switching between the different tasks, so the context will always keep switching. So, this is known as the context switching. Now, when a processor switches from one task to another and the processor may have to come back to the main task which it was performing. Now, the context related to that task should be saved somewhere, so that it becomes easy for the CPU to retrieve the context again. So, this saving of the context related to the previous task is known as the context saving. So, this is what it has written. When a task switching happens, the current context of execution should be saved to retrieve it at the later point of time. This is known as context saving. So, when it will be required to retrieve it, that when the CPU executes the process which is interrupted concurrently due to the execution switching. Suppose a particular task is being executed and some interrupt arrives. Obviously, if the interrupting process is of higher priority, then it should be executed first. So, the ongoing task will be interrupted, it will be stopped there only. The context related to that task will be saved, so that it becomes easy to retrieve it again after the execution of the interrupting routine. So, that particular interrupting subroutine will be executed, and after that the previous task which was interrupted in between, it will be retrieved, and the context related to that task will be obviously retrieved. So, this is known as the context retrieval. So, during context switching, the context of the task to be executed is retrieved from the saved context list. This is known as context retrieval. So, now we are clear with all the ideas of context switching, context saving and context retrieval. So, these are the very important terms related to the multitasking, because in multitasking this is what always happens when we are switching between the tasks. We can categorize the multitasking in different ways, like the various jobs can be accepted from the same user or different users. So, based on this criteria, they are categorized as single user multitasking and multi-user multitasking. Depending upon how the task or the process execution switching act is implemented, these are classified as cooperative multitasking, non-preemptive multitasking and preemptive multitasking. In this case, the execution switching means the way the tasks are being switched from one to another, that on that basis these are categorized. Like in cooperative multitasking, if the tasks are cooperative with each other, if the tasks relinquishes the resources on its own, it relinquishes the CPU on its own, then only the other task can take hold of it. This is known as the cooperation. If the one task is non-cooperative with another, then no other task can have the hold of the CPU. So, this is known as the cooperative multitasking. Now, in non-preemptive multitasking, there is no such scope that until and unless the task is completed, it will be preempted, like the CPU will be free for the further execution of another processes. So, this is non-preemptive multitasking. In preemptive multitasking, there are certain algorithms based on which the CPU is freed in prior to the completion of the task. Even if the task is not completed, then also there are certain algorithms which will make the CPU free in between, so that some other tasks can take hold of it and can use it. So, these are certain ways that depending upon the switching process and the execution switching process, they are categorized. So, in further slides in further lectures we will see what are these categories like cooperative, non-preemptive and preemptive multitasking. Let us have a small discussion about the cooperative multitasking. It is the most primitive form of multitasking in which a task or process gets a chance to execute only when the currently executing task or process voluntarily relinquishes the CPU, that is, it leaves the hold of CPU. Means if one task is being performed and it is having the hold of CPU, in between some other task comes which also wants the hold of CPU. Now, if the previous task wishes to leave the CPU or let the other task take hold of the CPU, then only the CPU can be accessed by another task, otherwise it will not be free to be used by other tasks. So, this is the case in cooperative multitasking. So, in this method any task or process can avail the CPU as much time. So, there is no limit on the time, that is why CPU can be free only if the task wants to let it be free. Since this type of implementation involves the mercy of the tasks each other for getting the CPU time for execution, it is known as cooperative multitasking. So, if some task is non-cooperative, then the CPU cannot be used by other tasks. If the currently executing task is non-cooperative, the other tasks may have to wait for the long time to get the CPU. So, this we can say that this is not an efficient system, because in this way one task will be keep on having the CPU in its hold, and all other tasks will keep on waiting for the CPU. So, this is not an efficient multitasking scheme. When we talk about preemptive multitasking scheme, it ensures that every task or process gets a chance to execute. When and how much time a process gets is dependent on the implementation of preemptive scheduling. So, there are different types of algorithms of preemptive scheduling, which will make sure that a particular task can have hold of the CPU for a particular time period, and then it has to relinquish it, it has to leave the hold of CPU. So, in this way all the tasks available in the system will be able to get the CPU once in a while and will be able to execute its will be able to complete the task. So, as the name suggests, in preemptive multitasking, the currently running task or process is preempted to give a chance to other task or process to execute. The preemption of the task may be based on time slots or task or process priority. So, it depends that what is the scheme being used or what is the algorithm being used. Maybe the task or process is preempted based on the time slots, in time slots scheme there will be a particular time period for which the task can be executed, and then it has to be preempted. And otherwise there may be some priority conditions with the task, that if the higher priority task comes in between or arrives in between the execution of the lower priority task, then obviously the lower priority task will have to leave the hold of CPU and the higher priority task will be executed. So, this is the way of preemptive multitasking. In the non-preemptive multitasking, the task or process which is currently given the CPU time is allowed to execute until it terminates or enters the completed state or enters the blocked or wait state, waiting for an input output. The cooperative or non-preemptive multitasking differs in their behavior as they are in the blocked or wait state. So, what it is saying that until and unless a particular task or process reaches the wait or blocked state, then before that the CPU will not be, the task will not be preempted, or the CPU, we can say the CPU will not be left for will be given to the other task. So, once the task is in the blocked or wait state, the scenario changes. How it is changed? In the cooperative multitasking, the currently executing process or task need not relinquish the CPU when it enters the blocked state. So, in cooperative multitasking, it was always the wish of the task if it wants to leave the CPU or not. But in non-preemptive multitasking, once the blocked task or the task which is waiting for an input output device is if the task is waiting for some input output device and it does not need the CPU anymore, then it has to leave the CPU. So, this is the difference between the cooperative and this non-preemptive multitasking. So, once either the task comes in the blocked state or the task enters in the wait state and it is waiting for the input output device. So, obviously, the CPU will not be needed by the task. So, in that case the task has to leave the CPU and let the other tasks use the CPU. So, this is the case which is different from the cooperative multitasking. So, this is what is indicated here. Now, we will see the differences between these two. In multitasking, the execution of more than one task simultaneously is known as multitasking, and in multiprocessing, the availability of more than one processor per system that can execute several set of instructions in parallel is known as multiprocessing. So, we all know this basic difference. Now, obviously, in multitasking the number of CPU is 1, but in multiprocessing the number of CPUs is more than 1. It takes moderate amount of time and multiprocessing takes less time for job processing, because there is not the switching between the tasks, but there is the availability of multiple processors. So, the many tasks can be executed simultaneously. In the multitasking, one by one job is being executed at a time. In multiprocessing, more than one process can be executed at a time. It is economical and multiprocessing is less economical. The number of users is more than one in case of multitasking. In case of multiprocessing, number of users can be one or more than one. So, it is not necessary that number of users is many in multiprocessing. Maybe one user is using the many processors. Throughput is moderate in case of multitasking, throughput maximum in case of multiprocessing. Its efficiency is moderate, and in multiprocessing the efficiency is maximum. Multitasking, it is of two types, single user multitasking and multi-user multitasking. In case of multiprocessing, there are two types of multiprocessing, symmetric and symmetric, based on the whether there is one processor which is which is responsible for performing the tasks of the operating system, that is working as a master device. Last point is number of user tasks is more than one in case of multitasking, and in case of multiprocessing number of user tasks can be one or more than one. So, these are the basic differences between multitasking and multiprocessing, and according to the application we can prefer any of these systems. So, this is the whole scenario which is differentiating the multitasking and multiprocessing. In multitasking, there is a single CPU and the operating system is being treated as a bridge between the CPU and the applications. So, these are the various applications, and the different applications can be treated as a single process. So, there can be multiple processors, and the CPU, a single CPU will keep switching on between different processes. But in case of multiprocessing, there are different processors, and each processors are having their own registers set and the cache memories, and in this way the multiprocessing allows different processors to which are responsible for performing the different processes simultaneously. That is all from my side on today's lecture. In next lecture we will discuss various types of scheduling schemes. Thank you.